Greetings and welcome to the Plsql channel, a series of video trainings on the Oracle Plsql language. My name is Stephen Feuerstein, and I'm a Plsql developer just like you. This lesson is part of my series on best practices for writing SQL statements inside Plsql blocks, and the focus is when and where to write SQL. Some quick reminders. If you haven't already done so, visit Plsql Obsession, a portal of resources for Plsql developers, at toadworld.com/sf. Lots of stuff there to find, but in particular, download the demo zip file, which contains scripts that I use in my demonstrations and lessons, including reusable code, performance analysis scripts, and simply demonstration of techniques. And also click on trainings, seminars, and presentations to access PowerPoints and other supporting documents for my various lessons. In addition, I strongly encourage you to read Bryn Llewellyn's white paper on the same general topic and the source for much of this presentation, which is Doing SQL from Plsql, Best and Worst Practices. So go to OTN, oracle.com/technology. You can just search for Doing SQL from Plsql, and that should get you to it. And that's a great follow-up from watching this video. In this lesson, I'll be talking about the following topics: setting standards and guidelines for writing SQL, why you should, take full advantage of the SQL language, hide SQL statements behind an interface, avoid direct calls to SQL in general in your application code, hide all tables and schemas that users cannot access, qualify every identifier in SQL statements, and qualify references to Oracle supplied objects, and avoid implicit conversions. Set standards and guidelines for SQL. Many organizations have coding standards. I'm sure you have a document that says how to format your code, how to name your program variables, etc. But very few organizations have standards for when, where, and how to write SQL statements. It's a very strange situation. We tend to take our SQL statements for granted in our applications. You just say, well, write it however you want to. It's so easy to do in Plsql, and Plsql is optimized to work with SQL. And while those statements are true, it doesn't mean that you should not have any standards for when, where, and how to write SQL. So why is a lack of standards for SQL dangerous? Well, think about it. SQL statements are just about the most critical elements of our application code. SQL statements reflect our business model, the underlying tables, the relationships between tables, expresses the basic way that we run our business. And those models are always changing. New tables, new foreign keys, changes to column names, changes to the types, constantly evolving data structures, which means that our code has to change along with it. Also, SQL statements cause most of the performance problems in our applications. Tuning SQL in the way that SQL is called in Plsql overwhelms all other considerations when it comes to tuning our applications. And many runtime errors result from integrity and check constraints on those tables. So think about it. Our code that has SQL in it is constantly changing. The hardest part of optimizing the performance of our applications is in the SQL statements, and lots of errors occur relating to SQL. That's a highly problematic set of statements to make about any part of the application code that we write. So set some SQL standards. Don't just let everybody write things however they want. At a minimum, here's my suggestion. Before you start writing your next application, just ask a very basic question. Do we want standards, or should we just continue doing whatever we want to do whenever we want to? It's a good starting point for the discussion on SQL, because if you look back and reflect on how you've built the previous applications, this describes our approach. Do whatever you want whenever you want to. And so simply ask yourselves as a team, do we want to keep doing that or not? And if not, then you've made a conscious decision to take a different approach. And then there are two things you should do. One is obviously to continue the rest of this lesson, this series of lessons in which I talk about key aspects of best practices, and therefore the standards that should direct how you write SQL. But also check out the Stop Writing So Much SQL lesson in my series on Say Goodbye to Hard Coding. In that section, I argue that every SQL statement you will ever write is a hard coding of the worst form, even worse than hard-coded literal values. and I provide a detailed set of steps that you can take to encapsulate or hide your SQL statements, which I'll be talking about a little bit more in this lesson as well. But the great majority of details regarding this topic and regarding a vast and a major change in the way you write SQL will be found in Stop Writing So Much SQL. But let's move on through all the specific recommendations. Fully leverage SQL in your Plsql code. Well, Oracle is continually adding significant new functionality to the SQL language as well as Plsql. And if you don't keep up with SQL capabilities, you'll find yourself writing code that is slower and more complicated and uses more Plsql than is necessary. I'm actually a good example of what you don't want to be. I'm a great Plsql developer, I suppose. I certainly write enough Plsql code. But I don't keep up with SQL, and I tend to do too much of my work in Plsql. That's one of the reasons that it's important to have a team of developers with different strengths. But in general, you've got to keep up with the new SQL features in the Oracle language. So every time a new version comes out, you should refresh your knowledge of what's available in SQL, take some online classes, do whatever's necessary to keep up to speed. Now, I'm not an expert in SQL by any means, but I asked a friend of mine, Lucas Yilma from the Amish consulting firm, to give me his suggestions of parts of the SQL language that have been enhanced recently in Oracle that you should be aware of. And here are his recommendations. First of all, analytical functions. For example, lag and lead that allow you to look at previous and following rows to calculate differences. The analytical functions have grown in importance and scope dramatically over the last several versions. And if you're not using these, you're missing out on a lot of functionality, and your SQL will likely be much more complicated than it needs to be. With clause subquery factoring, you can now create essentially definitions of named views inside a query and then use and reuse those queries, essentially allowing you to do a kind of top-down procedural logic inside your query itself. Let's take a look at an example, actually from Lucas. This is an example demonstrating Plsql, which is a great new feature for coding standards and analysis. And here's an example of a with clause that says with identifiers. And this is the identifiers, the new inline identifiers view. And then in my next with clause, my global section view, I can do a select from my identifiers view. So I avoid repeating the same subsections of code or SQL statements, and my resulting pieces that I build on top of those other pieces are much, much simpler, even though they can still be quite complex. Here's a join between identifiers and global section, two of my other with clauses. So check out the with clause. It's probably the most important new feature in SQL in terms of formatting your SQL statements so you can understand what the heck is going on. Flashback query gives you the ability to look at your data, your set of tables as they were at a certain point in time in the past. Your DBA has to set this up to find how much of a period of time it'll support flashback for. But essentially with flashback query, you don't have to worry about keeping track of or managing journal tables, history tables, and so on. Let the underlying database technology do it for you. ANSI join syntax, you just saw an example of this. You now have multiple ways or two different ways of doing your joins. Here's the new way of doing a join. Join this with this using that column name. And of course it can be much more complex than that, but many people prefer the ANSI join syntax, now supported. Sysconnect by path and connect by root give you some additional capabilities in the connect by start with hierarchical queries that Oracle has had since the early days, and is a very powerful feature. Scalar subquery. You can now, within the select list, add a select statement that returns a single value. So you don't have to do a join with a table or an inline view down here that kind of mimics the construction and return of that value. Just put it right inside your select list. Lots of great stuff. Lots of things to keep up with. So it's extremely important that you have this basic knowledge, your working knowledge of SQL, kept current at all times. Otherwise, you'll end up writing a lot of Plsql code that's just unnecessary and probably too slow. So, hide all tables and schemas users cannot access. This is a fundamental issue of control and security. And the basic idea is you should never allow users to connect to any schema that contains tables. Because if they can connect directly to that schema, they can do whatever they want with those objects. unless you put in place some underlying DDL triggers to not allow drops and so forth. But most organizations don't do that, and allowing access to a schema gives you an incredible amount of power. So instead, define the tables in other schemas, and then grant access via privileges, hopefully mostly roles, by providing grant of executes on packages that maintain the underlying tables. This idea also links up with stop writing so much SQL in my Say Goodbye to Hard Coding series, in which I argue that you should in general not write SQL statements in your Plsql code, but instead call programs that do the work for you. And this is an example of precisely that. So I have a separate schema called OE-data that contains all of my data. A user never connects to the OE-data schema. I have a separate schema called OE-code that contains all the code that operates on these tables. And this schema has execute authority, has all the underlying direct grants needed to manage the tables in this schema. So when you connect as OE-code, you can delete from the table, drop tables, etc. But no user is allowed to connect to this schema either. So both of these schemas are hidden away, are protected. Users never access them directly. Users connect to a schema that may or may not have any code, any data in it at all. Certainly not the application objects. And instead, the DBA will grant execute authority on the package. And then while Sam, the salesperson, is calling the order management package, when it's defined as a definer rights program, then it has all the privileges that the OE code schema has to execute this code and to modify the data underneath or referenced by those packages. So, you have a separate schema for all your users, or obviously multiple schemas. No direct authority to modify any database objects. The only thing you can do is execute code, and that code controls all the access to the tables. And this kind of approach gives you a very strong amount of security and minimizes the chances of any outside user maliciously affecting your application, or even an internal user who's supposed to be working with this data make a mistake and cause a tremendous disruption in production activity. So, your user schemas have no direct access to underlying database objects. Best approach to go. Qualify every column and identifier in your SQL statement. This recommendation has been around for a long time. It improves readability, but in these later versions of Oracle it can have a much greater impact as well. So let's take a look. Qualify every column and identifier in the statement. So here's an example of a select statement inside a procedure. And yes, Oracle lets us write native SQL statements directly in our Plsql code, which makes it very nice, very readable, but also makes us lazy. And we should watch out for writing these kinds of statements over and over again throughout our application. But when we do, notice I have a reference to a column, employee ID, and I have a reference to a parameter, employee ID in. And I know that it's a parameter because I'm following my naming conventions of underscore in, and then I select the last name into the local variable for last name. So this is a very common way to write our Plsql code, and we say to ourselves, well, I can reference my column name without any kind of qualification. And also I can reference my parameter directly inside my SQL statement, and there's no problem doing that the way I'm doing it here because the name of my column is different from the name of my parameter. And in fact, I have a naming convention to distinguish between the two. But wait a minute. What if the DBA adds a column called employee ID underscore in? They don't know about all my naming conventions. They know how they want to name their columns. So that's a perfectly valid database column name. And if I haven't qualified my references to my variables and my columns inside my SQL statement, when the DBA adds a column called employee ID in, my code will be invalidated, it will recompile, and it will still quote unquote work, but we'll get some really, really strange bugs. So that's the biggest reason to always qualify references to your variables and your columns. And in addition, in Oracle 11g, by fully qualifying your references, and I'll show you what I'm talking about here in just a second, you minimize invalidations of dependent program units. Under the effective management of Plsql applications, another video series, I talk about fine-grained dependencies in 11g, in which Oracle will track dependencies down to the column of a table. So if your program doesn't work with a certain column in a table, and that's the column that changes, Oracle will not invalidate your program. And if you fully qualify all references to every single element, column, and variable inside your select statement, then Oracle will have further information available to it when it compiles your code and maintains the dependencies. And as a result, it will find even fewer causes to invalidate your program. So the basic idea is that whenever you reference a column in a table, you preface it with an alias, which is what I've got here, or you can use the full table name. So e.lastname, e.employee ID. And then, if you reference a variable or a Plsql parameter, you use the name of the scope. For example, the name of the procedure can be put in front of your variable name. So abc.employee IDN. And now, even if the DBA comes along later and adds a column called employee IDN, it will not be in conflict with my procedures parameter, because the names of procedures and the names of tables are in the same namespace. You can't have a procedure or, in general, a Plsql program unit with the same name as a table. So if you fully qualify all of your references, you'll never have any ambiguity. Oracle will not be able to introduce a problem, or it will not inadvertently be introduced when you add a column that has the same name as a parameter. And Oracle will be able to fully leverage all the work you put into designing your SQL statement to minimize invalidations of dependent program units. This is one of those best practices which is kind of a pain in the neck. We often don't want to have to go to the trouble of doing all those qualifying of your names, but it's worth it, and you should try to take the time to do it. Qualify all references to Oracle supplied objects with sys. Another best practice that you hate to hear about, and it's hard to argue with, but you really don't want to do it. So, the recommendation is that whenever you reference a built-in package, be it DBMS output, DBMS SQL, any of those built-in packages, you always put sys. In front of it. Why is that? Well, it has to do with code injection. The possibility of somebody injecting their own malicious code into your code, making your application do things that you don't want it to do. And this is covered in much more detail in best practices for dynamic SQL, which is where code injection occurs. And the bottom line is that if you look at this very simple example here, a person calling my program could add a piece of code to finish up my SQL statement, and then inside that code could add a semicolon, which basically says terminate the SQL statement that you are executing dynamically and start executing code of my own. So that's what a dynamic SQL statement with concatenation can cause to happen. Let's take a quick look at the script, code injection. So here's a piece of dynamic Plsql code that concatenates in a where clause. And this kind of concatenation, where you're combining chunks of text to create your SQL statement, can lead to code injection problems or SQL injection. And so I can call this program and finish up my SQL statement, get the row for employee ID equals 101, and then add this other stuff that will create, for example, a procedure that will execute whatever I want whenever I want it. So this is the kind of thing you want to stop in general. And again, you'll find lots more detail in my best practices for dynamic SQL series. But one of the most massive kinds of injections that a user could do is to create or replace packages. So they could create a package called DBMS output in my schema that mimics the user interface of the built-in DBMS output package. And therefore, all subsequent calls to DBMS output.putline would call their code, not the built-in code, which is a pretty serious injection. So the way you do that is whenever you reference any of the built-in packages, for example, DBMS assert, which is a package Oracle has provided to help us validate SQL statements and the database object names to again minimize the chance of injection, you should always put sys. In front of it. And here's another one. Sys. DBMS output.putline. Now, even if the user, the malicious user, injects a package called DBMS output or DBMS assert in my schema, Oracle will not get confused. It will not try to call your or the hacker's DBMS assert because it says sys. It will call the sys. Package, the package owned by sys. Now, if somebody's managed to invade your sys account and start creating new packages there, you've got a much bigger problem. But at least if you prefix all your package names with sys. You will greatly minimize the chance of that particular form of injection. that somebody can do an end run and around your code and completely redefine entire packages. So next steps, that covers the topics in this series. Download the demo zip, check out the sample code, and run it yourself to try out the different things I talk about in this lesson. And then watch the other lesson in this series. And we'll talk about writing SQL in Plsql and leveraging key features of Plsql. So I'll talk about the key features of the language that you have to be using if you want to leverage and use SQL properly in your Plsql code. And hopefully you'll get a lot out of that. So thanks for joining me, and happy Plsql.